Hello, my name is Ron Hairston. Do you, a family member, a friend, or a neighbor live within 2,000 foot of the electric transmission line proposed by the Plains and Eastern Clean Line project? Will your home be close enough to suffer financial damage due to its proximity to the hissing noise emanating from a 600,000 volt DC transmission line? Do you believe the U.S. Department of Energy's environmental impact statement that corona noise from the transmission line will have no lasting measurable effects on you or your property value? The noise simulation in this video may help you answer these questions. Before we begin, let me tell you a little bit about myself. I'm a retired engineer, having worked some 35 years in the energy industry. In addition to design, I've also held positions in marketing, sales, management, business development, and strategic planning. My varied experience helps me to identify problems that may otherwise be overlooked. Corona noise from the high voltage DC electric transmission line proposed by Plains and Eastern Clean Line is one problem that needs our full attention. After receiving a belated notification from Plains and Eastern Clean Line a few weeks ago, I began to pore over the 3,700 pages of documents they sent me for review. While I may have many concerns, most troubling is the potential for financial damage to homes caused by corona noise emanating from the 600,000 volt DC transmission line that will come close to my home and the homes of many others, possibly such as yourself, in the path of the Clean Line project. For this reason, I tried to organize information about corona noise in a way that may allow one to estimate just how loud corona noise might be at various distances from the transmission line. Clean Line seems to dismiss our concerns, stating in the environmental impact statement, or EIS, that first, corona noise levels are below EPA guidelines, and there is no physical harm, presumably, to our hearing. Second, the EIS and technical reports claim that background or ambient noise will drown out all or most of the hissing and crackling of corona noise except for locations that are within about 150 feet of the line. Third, the EIS states that even if the sound is audible, it will have no lasting effect on our home or land value. It says that people should have little trouble sleeping indoors, especially with their windows closed. This statement should raise our awareness that corona noise may have one or more adverse impacts on the lives of anyone near the 600,000 volt line. So as you can see in this slide, we're going to estimate corona noise over distance, mix it with background noises to see how well the damaging effects of this noise will be masked, and using our ears listening to the sound in the simulator, sense to what degree it may impact home or land values. As it pertains to noise impacts caused by corona noise, the EIS relies on a number of broad assumptions without any supporting information. It then draws conclusions without the level of detailed information one would logically demand, especially when unprecedented financial damage to the public may be a real concern. Measurable information about corona noise and its reaching effects is hidden from view. It's not published as part of the printed EIS sent to the public for review. Much of the corona noise technical data is located in two reports that can only be found in the often overlooked Clean Line Reference CD. Two important reports buried in the CD are the Noise Technical Report and the Electrical Environmental Assessment Report. This is where most of the information was found that allowed me to construct the corona noise simulation we will use in a few minutes. One of the most enlightening pieces of information describing the magnitude of corona noise over distance was found in the Electrical Environment Assessment. I don't understand why this critical piece of information was left out of EIS Chapter 3.11 that is devoted to noise and its impact on the public. It makes one wonder if Clean Line deliberately wanted to hide this information from public view. Looking at the graph, we find that engineers have estimated what the average annual level of corona noise would be under fair and foul weather conditions. This begs the question, what is the peak level? When does it occur and for how long? The units of noise level are expressed as decibels or dB. The A in dBA means that the levels have been normalized for the human ear and how it perceives changes in noise across different frequencies. As you can see in this graph, the decay of noise level is not linear. It's not a straight line. You may be interested to know that there is roughly a 6 dB change whenever the distance is halved, or a minus 6 dB change when the distance is doubled. This could be useful information when attempting to understand what the corona noise level may be beyond the maximum distance shown in the graph. Thinking about how the human ear responds to changes in sound level, we should recognize that a doubling of a dB level does not mean that the sounds we hear will be twice as loud. Noises that we hear as twice as loud corresponds to a 10 dB increase. For example, a noise at 30 dB will sound twice as loud at 40 dB. If a 30 dB noise increases to 60 dB, it is doubled 3 times, once for each dB change. It will then sound 8 times louder. The ROW solid lines mark the distance from the center of the transmission line that is theoretically centered in a 200-foot right-of-way. The dashed lines at plus and minus 75 feet correspond to a 150-foot right-of-way. In this graph, reaching out 500 feet to either side of a 600,000 volt DC transmission line, we can see that at the center of the right-of-way, the noise level averages about 55 dBA during fair weather. At 500 feet from the center, the corona noise drops to an average 40 dBA. Because corona noise at 500 foot is still somewhat loud at 40 dBA, and the fact that the curve shows a less steep decline as the distance is greater, we should be concerned about corona noise levels well beyond 500 feet. For that reason, I've extended the graph to span a greater area of concern that better corresponds to noise concerns homeowners would logically have at greater distances. This graph extends the fair weather curve to 1,000 foot, where the noise level drops to 35 dBA. As noted by a blue arrow pointing beyond 1,000 feet, the level drops to about 30 dBA at twice that distance. Corona noise that far away from the transmission line would be equivalent to our listening to a soft whisper some 15 foot away in the hush of a library setting. For reference, I've also included in blue a number of familiar sounds and their typical noise levels ranging up to 55 dBA. I'll give you a few moments to review these. Okay, now the fun begins. Using an audio program, I've embedded 5 carefully calibrated sounds that include actual corona noise, 3 background noises, and pink noise that we will use for adjusting the volume control on our playback devices. As you can see, the audio signal on top has stepped amplitudes. The size of the steps in corona noise are 5 dBA, beginning at 30 and ending at 50 dBA. This corresponds to noise levels beginning at 2,000 foot at the left and ending at 125 feet on the right. This slide provides some additional detail regarding the 5 noises included in the simulation. While the recorded corona noise used comes from a 230,000 volt DC line, the levels are adjusted to correspond to that of the 600,000 volt line planned by Plains and Eastern Clean Line. Next, I actually recorded the second noise from outside my bedroom window on a cold, still night. The rural area where I live is very quiet. Naturally, we are concerned about how corona noise will likely degrade or destroy the value of our home. That value is markedly driven by the serenity found here. The third noise is a combination of gentle wind blowing through tree leaves with an interspersing of chirps from our winged friends. This is a peaceful noise commonly enjoyed by many of us. Next, we don't have running streams or brooks on our property. However, the soothing noise of water running in a brook was added to provide a degree of variety of natural noises that others in rural areas may value. The last noise is pink noise, and as mentioned earlier, it will be used only as an aid in our calibration of volume settings in order to adjust the response we hear from our speakers or headphones. The levels of all 5 audio signals have been carefully set in an attempt to obtain the most realistic corona noise simulation possible using the information and tools that I have available. This slide simply shows a close-up view of the steps in corona noise mentioned earlier. Now it's time to begin calibration or adjustment of our volume controls. Be sure you're doing this in a quiet place so that you can obtain the best sense of noise changes during the simulation. When I begin the pink noise audio, adjust your volume control so that it can just barely be heard like a whisper some 15 feet away. The pink noise is now being turned on. The pink noise is now off. If you want to repeat the adjustment, rewind this video and try again until you feel comfortable that the volume control is set as it should be. In a few moments, we're going to validate our volume setting by listening to night background noise. With the exception of a barely audible bump, the background noise should be at or below the lowest levels of hearing ability. If you can clearly hear background noise, the volume control may be a bit too high. If you can't hear the very low sounding bump, the level may be a bit too low. 5 passes will be made so that you can fine-tune your volume control. Okay, the night background noise is about to play. Listen very carefully. The noise is now stopped. Did you hear a faint thump where indicated by a circle? If needed, rewind and replay until you can hear it. When you can hear the bump, the rest of the noise played may be so low you can't quite hear it in the background, and that's pretty much as it should be. Now that our volume control is adjusted for the most accurate response to our simulation, we can get down to business. Before I start playing the corona noise with the backdrop of quiet winter ambient noises typical in many rural areas, let's review what we should expect to hear. First, after 10 seconds of background noise only, there will be increasing levels of corona noise every 10 seconds. The beginning of corona noise that is 10 seconds into play of the simulation should produce a barely perceivable increase in overall volume. This amplitude of corona noise simulates 2,000 feet of separation from the transmission line. The next step in corona noise beginning at 20 seconds represents a 1,000-foot distance. It should be recognizable but still fairly low. The next two steps of increased volume due to the hissing of corona noise begins at 30 and then 40 seconds and should be easy to hear. The final 50 dBA level beginning at 50 seconds corresponds to 125 foot of separation from the transmission line or source of corona noise. As you listen to it, the level of hissing and crackling should be loud enough that it starts to interfere with human conversation. Are you ready? We'll now play the corona noise mixed with winter night background noise. This playback segment is now ended. Did you get the levels of audible noise I described a minute ago? What was your perception of these noises? At what distance are they loud enough to impact your home value? Please feel free to repeat this part of the simulation as much as you need to. If you are satisfied for now, we can go on to the next step of the simulation and evaluate corona noise against the backdrop of daytime rural noises. This simulation step is similar to the first. However, the background noise used here will be greater, as one might expect, as it simulates noise during the daytime hours of summer. When we play the simulation, you should be able to hear the hushed noise of gentle wind brushing through tree leaves. Birds will also be heard chirping in the distance. If you are ready, here we go. Listen to the low and peaceful sound of nature mixing with intrusive corona noise as hissing noise steps up in volume when approaching the transmission line. How did that go? Did you experience that corona noise may intrude against daytime levels of background noise at 1,000 foot or most certainly 500 foot? Feel free to rewind and replay if you like. Otherwise, we'll go to the last simulation step. All right, now we're going to add a little babbling brook noise. The sound of flowing water will be in addition to the daytime noises of gentle wind and distant birds used in the last sim step. Surprisingly, when I ran this sim, I thought we might observe a notable improvement of sound quality stemming from the relaxing sound of babbling water as it neutralizes the hissing of corona noise. Well, let's see what your observation is. The mix of these three sounds is about to play. What did you find? Did the sound of water do much to mask the hissing of corona noise? Do you want to rewind and replay this step of the simulation? If not, we will move on to a few remaining slides that will sum up our findings as we ran this corona noise simulation. There are some factors not measurably addressed in the EIS, in the technical reports, or in the simulation we just ran. They include forest or a dense stand of trees that may be in between a home and the power line producing corona noise can attenuate or block some of the noise. This may reduce the probability of a home suffering financial loss from the irritating nature of this hissing and crackling electrical noise. On the other hand, terrain can have the opposite effect. The shape of hills and valleys function like an outdoor amphitheater, channeling and amplifying sounds. Even low-level noise carry for quite a distance. As a case in point, I can hear people chattering at a lake over half-mile away from my deck that oversees a valley, a lake, and two mountain ranges rising beyond. What's troubling in the EIS and technical reports is that there is no disclosure of calculated corona noise level data used to produce the graph we saw. There is no data to back up claims like no adverse impacts were found. It's only limited to a couple of dBA levels that express an average of varying conditions. What are the peak corona noise levels for what duration should they be expected to last? What are the calculated effects of temperature, humidity, and wind direction? What other factors should be considered when presenting calculated data for corona noise propagation? Many home and landowners have site-specific factors like the degree of forestation and other noise attenuating factors. Many have a variety of elevation and topographical factors that may accentuate rather than attenuate noise as it travels beyond the range modeled in the EIS or in this simulation. The bottom line? Predicting levels of corona noise may often be so uncertain that it will not be known until the transmission line is placed into operation. Only then will we know the full impact of corona noise on the value of our homes and other property. So, what conclusions can we draw from our analysis using this simple but revealing corona noise simulation? The EIS conclusion regarding the propagation of corona noise is grossly understated. Irritating levels of noise levels that are unacceptable to homeowners, extend far beyond 150 feet as claimed by the Electrical Environment Assessment Technical Report. The simulation strongly suggests that corona noise may be heard up to and possibly beyond 2,000 feet away. The probability of this happening increases during the quiet of winter nights in rural areas. In a similar manner, the simulation points to the fact that corona noise is not easily filtered out. Irritating hissing may be heard 1,000 foot or more beyond the transmission line, even during daylight hours when background noise levels are higher. The intrusive nature of corona noise and its difficulty of being masked by other background or ambient noises gives sound argument to how it will have an adverse impact upon the value of homes and other sensitive property far beyond the line and easement. The conclusions in turn lead to imperatives or critical actions that must be taken to minimize real unprecedented financial losses that home and other property owners will bear as a result of their proximity to the emitter of corona noise. The use of government lands as proposed in the Approval Act should take priority to prevent large-scale loss of property values in family savings. Where the use of government land is unavoidable, home and other property owners must be justly compensated for their losses. Because the negative financial impact of corona noise respects no easement boundaries or property lines, adjacent home and property owners must be fairly included for just compensation. Property owners also have imperatives. As shown in this slide, they need to bring light to erroneous conclusions about the impact of corona noise as found in the draft environmental impact statement. Comments should go to the Department of Energy that make the point that the far-reaching effects of corona noise leads to unprecedented injustice for home and landowners. The unintended consequences of the use of advanced technologies found in sections 1223 and 1224 of the 2005 Energy Policy Act are too egregious to bear. Therefore, DOE should not grant Cleanline LLC right of eminent domain. Write and telephone our elected leaders in Washington. This includes members of the Senate Energy Committee. Ask them to expedite passage of the Approval Act. Ask them to make sure DOE does not grant eminent domain status to Cleanline. Ask them to find ways to mitigate losses due to corona noise and its far-reaching impact on the lives and fortunes of those affected. This slide has contact information for our elected leaders in Washington. Pause the video or press the screen print button on your keyboard if you don't already have this information. This is a graphical representation of many of the issues we just talked about. Observe how property owner A, an adjacent property owner not under the right-of-way, can suffer much greater loss than owner B, whose land is directly impacted by the line and right-of-way. This graphic provides a good concluding summary and is supported by the corona noise simulation we just conducted. Corona noise does have far-reaching and real financial consequences for home and other property owners who have been systematically excluded from just consideration in the EIS. What will your response be?